we have covered everything about Karnaugh maps. Okay, 2 variable, 3 variable, even 6 variable we kind of covered. Let's look at Karnaugh maps from another point of view. And this time we look at it from situations that you might not care. Okay? We're going to be looking at don't cares. Okay? Well, why do we look at something we don't care about? Because something we don't care about can give us an advantage in smaller maps. Okay, so this is the key thing. If you don't care about a certain input combination, what happens to it? If your output is not important for that particular input combination, you have the choice of taking that output as a 1 or a 0. Taking it as a 1 or 0 will give you the opportunity to come up with more larger Karnaugh maps. Okay? Or better mappings. So let's talk about donkers. What I'm going to show you is a BCD converter or 7-segment display converter. This is the hardware that you use for displaying numbers. So you have 4 bits here, if a 4-bit BCD number ranging from 0 to 9. And this is the least, this is the most significant bit, and this goes between 0 to 9 decimal. And then you want to have a piece of hardware that would be driving a 7-segment display thing, okay, with segments A, B, C, D, E, F, and G. And since this is a BCD number, it goes only from 0 to 9. Means 10, 11, 12, 13, 14, and 15 don't matter. Okay? If these don't matter, that means you don't really care about the output. What it means is it doesn't matter to you if 1010 happens on the input, because this is not between 0 and 9. What displays because of this, it's not important. Okay? So I can do either set them all to zeros or set them all to ones, or I can make them don't cares and then choose whichever I want. Let's do this for one of the outputs. I'm going to take output A, for example. See, the input 0000 displays as 111111. This is 0. Input 0001 is this. Input 2 is this. Input 3, I'm showing it this. Input 4 is this, and so on and on. Okay? And input 9 is this. Now, let's look at individual outputs. For example, segment A. Segment A is 1 for 000 input. Segment A is 0 for 0001 input. Segment A is 1 for 0010. Segment A is don't care for 111011 1010 1010 1100 1110 and 1111. I don't really care what happens to segment A. Okay? And therefore my Karnaugh map for segment A becomes this. Okay? 2 zeros there. 1, 2, 3, 4, 5, 6, 7, 8 ones there. 1, 2, 3, 4, 5, 6, 7, 8 ones there, 2 zeros there, which you are seeing, and the yellow ones, you don't care. Okay, since you don't care, I'm gonna put dashes. And when I'm mapping, this is what I'm gonna do. When I'm mapping, I take the don't cares the way I like. For example, look. If I treat the 4 don't cares on the lower left, lower right, that gives me a very good map. Okay? If I treat these don't cares as the two below as ones, then that gives me a relatively good map also. Then I have a 1 up on the left hand side. That 1 on the left hand side is, let me use a different color here. That 1 on the upper left hand side can be mapped with this. I don't really need any don't cares there. I have one more 1 left, and that one more 1 is this. Okay, see what I did. I'm checking to make sure that I haven't made any mistakes here. What I did was I selected some of the don't cares as ones, and they helped me form larger maps. Some of the don't cares as zeros, like this one over here. That's only one the only one that actually no. Actually no. Okay. So actually I'm using all the don't cares as ones to give me a good map. If I had decided that no, all the don't cares have to be zeros, then I would have isolated ones everywhere. And this map, let me do the prime implicants. The prime implicants do consider the mean term, the don't cares. I'm sorry. The prime implicants do consider the don't cares, but when you are doing the essential, you don't consider the don't cares. So this one up on the left and the one below, that's an essential one. This one is an essential one. This one is an essential one. And okay, this one is an essential one, but then let me tell you, this is not essential. Okay, the dark green one is not essential because this one is covered by the dark green one, and also is covered by this map on the lower right. Okay, and therefore my solution would be, for this particular example, would be, let me write this down. This is y for the big one, and then for the one on the upper left and lower left is or width, y bar, z bar, x bar. Okay, let me write the essentials first, and then I have z, x. Okay, these are all essentials. And then I have 1 down below that can be covered by 2 maps, either this. Which is y bar w, or this, which is w x bar. Okay. Now, this particular example, I use all the don't cares for as ones. Let's do another design. This one, I want to do a circuit that detects prime numbers between 2 and 11. So this is the circuit I want to build. The circuit has 4 inputs, A being the most significant, B, C, D. Okay. And it has one output, let's say P for the prime, or it's W, for the prime number detection. And let's call this one prime between 2 and 11. I want to build this circuit. Okay. So let's do the Karnaugh map. I'm going to do the Karnaugh map on the left side, prime numbers between 2 and 11. So as soon as I say that 0, 1, these are don't care. 0, 1, these are don't care. 11 is good, 12 is don't care. 12, 13, 14, 15, these are don't care. Okay? Now let's put the ones in the map. 2 is considered because between 2 and 11, so 2 is good. Okay? Is it a prime number? Yes, it is, and therefore I put a 1 here. Okay? I put a 1 here. 3 is a prime number. How about 4? It's not. Therefore, you put a 0 here. How about 5? 5 is. 6 is not. 7 is. 8 is not. 9 is not. 10 is not. 11 is. 12, forget it. The problem says don't care about that. Okay? So this is the map I have. Now I'm going to form my prime implicants. Okay? I'm going to form my prime implicants. When forming my prime implicants, I will be looking at all my... let me show you another map here. Let me put another map here that I will work on. A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0, dash, dash, 1, 1, 1, 1, dash, 1, dash, and then 0, 0, dash, dash, 0, 0, 0. All right. Let's do the prime implicants. See, this is a prime implicant. Okay. Nobody else completely covers it. This is a prime implicant. Nobody else completely covers it. Okay, I'm treating my don't cares as ones. Now, in forming the prime implicants, I treat them as ones. So, what else I have? I have this is a prime implicant. Okay. Nobody else completely covers it. This is a prime implicant. Nobody else completely covers it. This is a prime implicant. The vertical one. Nobody else completely covers it, but then it is don't care. It has all don't cares, but for now, I don't care that they are don't cares. I treat them as ones. Do I have any more prime implicants? I don't. So let me zoom on this. Okay. So I have 1, 2, 3, 4, 5 prime implicants. Now let's look for the essentials. When I'm looking for the essentials, there I don't care about the don't cares anymore. What I say is, well, when I'm looking for essentials, I will only consider the ones. So still, if there is any one not covered by any other prime implicant, then that is essential. This is a real one, not a don't care one. And therefore, this one qualifies the blue map for as an essential implicant. Okay. This one qualifies this as an essential prime implicant. Okay. That's it. These are the only two essentials that I have. Look, the blue one is essential. The one that I'm showing in green is essential. Okay? If I consider these two essentials, have I covered all my ones? Don't care about don't cares. Have I covered all my ones? The blue one covers everything on the left hand side. The green one covers the row in the middle. But then I will have one that is covered by either the dark red map or the light red map. Okay? And there, none of them are essential. So I choose one of them. I can choose either this one, or I can choose this one. Both solutions are good. Okay, both solutions are good. Notice that the one on the left treats these two don't cares as zeros. The ones on the right treats these two don't cares as ones. What it means is if a don't care comes in, for example, 1101 comes in, this one is going to give me a 0 for 1101. This one is going to give me a 1 for 1101. But see, 1101 is 13, and 13 is not in the range anyway, so I don't really care. Let's do another one. 1111. 1111. The one on the left is gonna give me a 1. Okay. It's gonna give me a 1. The one on the right is also gonna give me a 1. Okay. It says 15 is a prime implicant, but see, 15 is not in my range anyway, and therefore it doesn't matter. Okay. The reason it gives me a 1 in both cases is because in both cases, it is covered by this essential map, the horizontal 4. That's it with don't cares. We go into max terms next.